Hello everyone. In this lesson we are going to solve linear equations with one or more variables using inverse operations, and we're going to get right to it with the do now. Jack paid an electrician X amount of dollars per hour for a 5-hour job plus $70 for parts. So just remember, we have this X dollars. We're looking for that. And it's a 5-hour job, $70 for parts, and that plus right there, the total charge was $320. So right away, I created an equation. I put equals, the equal sign, and 320 right after it, because I know that is the total. A 5-hour job, that is 5 and then X, because that's X dollars per hour. 5 hours, 5X plus 70. So there is your two-step equation, nice and easy. 5X plus 70. And then it says solve the equation. So that's what we're going to do. 5X plus 70 using inverse operations. What we do is we try to isolate the variable. You subtract 70. You see that addition sign right there. That means you have to subtract. The opposite of addition is subtraction. That cancels out, and we have 5X equals, and then 320 minus 70. Always bring your calculator up, do 320 minus 70, even though you might know what it is, and you probably should know what it is. It is 250. And then this is multiplication, 5 times X, so that's why we're dividing. We divide by the coefficient, which is the number next to the variable. And that should be 50. And just remember, you do 250 divided by 5, enter. And that is it. So X equals 50. What does the X represent in the equation? In this equation right here, this is what they want to know. So right there, what does the X represent? Well, the X represents X dollars per hour, the amount of dollars per hour. And right there, the amount of dollars the electrician made per hour. So $50, this is what the X equals. So when you solve for that X, it's really important to actually know what you are solving for. And that is $50 per hour. And that's why the amount of dollars the electrician made per hour, that's exactly what the X represents. All right. So just a little bit of a review. The subtraction property of equality is when you are subtracting on both sides. So just remember, if you see X plus 7 equals 10, you can just go ahead and subtract 7 on both sides using the subtraction property of equality, and X equals 3. The way to check that is take this 3 and just substitute it in for the X. X plus 7 equals 10, and 10 equals 10. I'm not really big on the check, but you should know how to do it. The addition property of equality is when you add on both sides. So if you see X minus 3 equals negative 4, that means that you are adding 3 on both sides, because that is the opposite. Negative 4 plus 3 is negative 1. Again, with the check is you substitute that negative 1 in to where the X is, and you get negative 1 minus 3. That is negative 4 equals negative 4, and you get a check mark. That works out. The division property of equality is when you divide on both sides. Just like that, we see multiplication, you divide the opposite. The 3's cancel and you get x equals 5. And to check it, you substitute that 5 in, and I'm going to put that in parentheses. And that would be 15 equals 15 and a check mark. Whenever you see division, that's when you multiply. So I'm going to multiply by 4 and multiply by 4. The 4's cross cancel. The x comes down, equals 12. 3 times 4. Now, when you substitute the 12 in for the x, it becomes 12 divided by 4 equals 3. And that is true. 3 equals 3, and that is a check mark. So that is the multiplication property of equality when you do it basically on both sides. Again, this is what we went over just now. The addition property of equality is when you add the same number on both sides. Subtraction property of equality is when you subtract on both sides. Multiplication property is when you multiply. And division property is when you divide on both sides. And here is a sample Regents question. When solving the equation, and there's the equation right there. So it looks pretty complicated. So I'm going to highlight it. Emily wrote this as her first step. Right? And I went a little bit too far. So what I usually and typically do is to actually see what the differences are between the first step, this original equation, and the first step. So I'm just going to rewrite 4 times 3x squared plus 2. It just helps me see it. Minus 9 equals 8x squared plus 7. And I'm going to look at the differences. Do you see that nothing changed in this first part, but the minus 9 is gone? So if this minus 9 is gone, there's only one thing that they probably did. They added the 9 on both sides because this became a 16 and that was a 7. So if the person did that, what would happen is that they would be trying to isolate the variable. This cancels, and then you would get 4 times 3x squared plus 2 equals 8x squared plus 16. And there it is. They added 9 to both sides, so it's the addition property of equality that they used. They did not distribute multiplication over addition. This right here would be the distributive property. Probably I would do that next. But that is not what happens in the first step. All right, so solving two-step equations, we're going to jump right to it. Again, let's use not distributive property, but inverse operations. If you see a minus 12, you add 12 to both sides. So if you're adding 12 to both sides, they cancel out. The minus 12 and the positive 12 equals 0. You bring down every time you take a step, just bring everything down. This is 30. And then when you see multiplication, you're dividing, again, inverse operations, and you get y equals 10. To check it, we would have 3 times 10 minus 12 equals 18. And that would be true because it's 30 minus 12 equals 18. And you would get 18 equals 18, and that's how you check it. That's a check mark. 2x plus 11 equals negative 19. Again, you see the addition, the plus 11, and you minus the 11 first. So this is now 2x. The 11s cancel out, and then this becomes a negative 30. You divide by 2 on both sides. X equals negative 15. And notice I don't have a check there. I just want to go over how to just go ahead and subtract the negatives on the calculator. This is the negative button right here. You put negative 19 and then you just do minus 11. That's what it is. So that's what I am going to put in, and that's negative 30. Just remember, when you do have negatives, negative 19 minus 11, that goes further left on the number line. So it would make sense that it goes further into the negative away from 0. And that is negative 15 right there. And we could go on to the next page. Those are two-step equations. Now, going to distributive property before it becomes a two-step equation, this is distributive property first. So we're going to solve the following equations. Let me move that up there. Every time you see parentheses, when we're talking about questions that have one variable, you're going to use distributive property to get rid of those parentheses. So 2 times x is 2x, and 2 times 5 is 10. And that all equals negative 8. You subtract the 10. Now it just becomes a regular two-step equation, and you just subtract the 10 on both sides. Remember, they cancel. This becomes a 2x, and negative 8 minus 10, going further from 0, is negative 18. It's like you're adding the numbers and keeping the sign. So you're dividing 2 on both sides because you see multiplication. The opposite of multiplication is division, and you get negative 9. So same thing goes for this, but by the way, you should always be aware that they will ask you to multiply by a negative, and that is something that you have to really concentrate on and say to yourself, negative times a positive. This is a negative 7a. Negative times a negative 2, that is a positive 14. And by the way, I'm going to erase this. See how my a looks like a 9. That is not good. So I'm just going to put that as an A and just make your A look like that. That makes it much better. But just this negative times a negative, please don't, like if teacher ever told you to bring down the negative, don't do that. This is negative times a negative. It's a positive. Be aware that that is going to happen. So this is a two-step equation. So you're just going to subtract 14 on both sides because you see addition. This cancels. You get negative 7a equals 0. And then you just go ahead. Don't worry about the 0. You're dividing by negative 7 on both sides using inverse operations, and a equals 0. And that would be your final answer. All right. So on the bottom here, I mean, these are a little bit like 8th grade level questions. Even these are really easy. But just remember, if you see a fraction, don't get crazy about it. Just do what you normally know how to do. Get this 5 over to the other side of the equal sign. Cancel it out right here. And because you used inverse operations to cancel it, and then the fraction comes down. And 1 minus 5 is negative 4. So just remember, when you have a fraction, a lot of people are going to divide by 2 over 3. You can do that. You could divide and cancel the 2 over 3. But it's just much easier to multiply by the reciprocal. When you multiply by the reciprocal, everything cancels out. The numerators and the denominators, they cancel. And I'll show you exactly what I mean. This cross cancels with this. This cross cancels with this. and then x comes down. You see how nice and easy that is. All right, and then you just take your calculator and you could just go ahead and multiply -4 times, and the way to get to the fraction symbol is either alpha x, and that brings up the fraction, or alpha y, and that brings up the other window. But 3/2, look how easy this is, because you don't have to do it by hand anymore, and it becomes -6. That is nice and easy. -6 is your answer, and that's it. So now when you're doing, remember what I told you, when you have parentheses, you just multiply, do distributive property, 3/4x plus, and let's take the calculator out again, and let's do 3/4 times 8. So alpha x, 3/4 times 8, and that's 6. Nice and easy. And now it becomes a two-step equation. You subtract 6 on both sides. Anything that you have a question about, even like if it's 2 minus 6, like this on the other side, 2 minus 6, then just go ahead and put it in the calculator. You have 3/4x. That is going to be -4. And then when you are faced with a fraction and you want to divide, don't do it. Just go ahead and multiply by the reciprocal, and it becomes a lot easier. 4 cancels with 4, 3 cancels with 3, x comes down, equals, and we have now -4 times, and I'm going to put alpha x, 4/3. And that's -16/3. -16/3. So if you have -16/3, you could divide -16 and 3 and get the fraction, and get the converted into a decimal, or you could press math, and you see how this it says decimal here. So you just press 2, and you notice that it goes to the screen, back to the screen again. Press enter. It's -5.3 with a line on top, because the 3 is going on forever. It's a repeating decimal, and that is it. So the mid-lesson assessment, again, it's pretty easy. Remember, you see parentheses. Just go ahead and use distributive property. 3 times a -2, positive times a negative. Yep, that is -6. So this is -18. Do the opposite of -6. You add 6 on both sides. The 6's cancel. You have 3x equals -12. Divide by 3. And x equals -4. That's it. Nice and easy. Distributive property first, and then use inverse operations. Okay, here's a Regents question. This is exactly what they would put on the Regents, and they did. But I don't want you to get really confused with it. Just think about what it is that you would normally do to start cleaning up the left side. When I say clean up, I mean let's start isolating the variable. So we're going to have this +10. I need to get that over there to deal with that fraction. So let's go ahead and -10 on both sides. I'm going to rewrite this. 2 times 5x minus 3 over 4 equals 14. And so far, I'm doing okay. So let's go ahead. I need to get rid of these parentheses because they're bothering me now. All right, so I'm going to use distributive property. This is 10x minus 6. That's all over 4 equals 14. Now, remember when I told you when you have a fraction, just multiply by the reciprocal? Well, we're not going to turn the whole thing around. This is division. So we're not going to flip the whole fraction. But what we are going to do is we're just going to multiply by 4 on both sides to get this to cancel. As long as you could do anything, the inverse operations, right? So I'm choosing multiplication because I see division. So I'm allowed to do it. If I multiply the same number on both sides, I'm allowed to do it. So this is multiplying by 4, and look what happens. They cancel. So I'm going to go over here, and it becomes 10x minus 6 equals 14 times 4. 56. Look what it becomes. It becomes a nice two-step equation. And I'm adding 6 on both sides. This is 10x equals 62. And remember, if you are confused or anything like that, there it is. Then you divide by 10. X equals 6.2. Let me just check to see if that answer is correct. 62 divided by 10, 6.2. All right, that is a Regents question. That's the level that you are going to have to, solve. Okay, so combining like terms. To be able to solve an equation, sometimes we must group like terms. If the like terms are terms that contain the same, like terms are terms that contain the same variable. They have to have it, like say an x has to have another x. They have to be like terms. So, or group of variables raised to the same exponent. So it could be like 2x squared plus 3x squared. Those are like terms. It would be 5x squared, regardless of the numerical coefficient, the number before the variable. All right. In your groups, we're going to discuss the steps that you must take before solving for the variable and then solve for the missing variable. So the thing is here, you have to combine like terms to get it to where we could solve for the missing variable. So when we're looking at a question like this, we see 3x and 6x. And you notice that that's 3x. When you're reading it, that is 3x plus 6x. That is 9x. You just bring down the plus 5, the equal sign, and the 24. Then that's a two-step equation. So you already know how to solve that. Use inverse operations. You subtract 5 on both sides, and the 5's cancel. You get 9x equals 19. And you're dividing by 9 on both sides. This cancels. And let me just take the calculator and just do 19 divided by 9. And it's 2.1. X equals 2.1 with a line on top, because it's a repeating decimal. For this one over here, same thing. We're going to combine the like terms. So we see a negative 3x and a positive 6x. You could put that directly into your calculator. What it would come out to be is 3x. You bring down the minus 2. Bring down the negative 20. The number before by the way, the sign before the number is the sign of the number. So this is a negative 2. So you add 2 on both sides. This cancels, and you have 3x equals negative 18. Again, this is multiplication, so that's why you're dividing. And x equals negative 6. That is negative 18 divided by 3. That's why it's a negative 6. I put a challenge question here, but I would like everybody to know how to do it. Just remember the 4x squared plus the 6x squared, they are like terms. And if they are like terms, that means you could combine those like terms. So 4x squared plus 6x squared is 10x squared. All you have to do is add the coefficients and keep the x squared because these are like terms. Then you have 10 times x squared, so you're going to divide by 10, getting rid of, using inverse operations, getting rid of the coefficient, canceling it out, isolating the variable, and this is 9. So now we're basically stuck right here. X squared equals 9 is not the answer. Remember the opposite inverse operations, you have to solve for x, not x squared. The opposite of x squared is square root. So we're going to square root both sides. And what happens is that they cancel out. It's like canceling out, like minus cancels out. Subtraction cancels out addition. Multiplication cancels out division. Squared cancels out square root and vice versa. So it's x equals, we're just going to put 9 for now. All right, and that is, I'm sorry, it's not 9. Square root of 9 is 3. So if you look at it, and I'm just going to go over where the square root button is. I went over this in a prior video. You press second function and x squared. You see that little blue up there? It brings that square root button up, and the square root of 9 is 3. And that is it. So in the prior questions, we would have the x's, when you just look at the screen before this, we'd have the x's, the variables, on one side of the equal sign, and just combine the like terms. But now we have x's appearing on both sides of the equal sign. So you have to get the variables on the same side of the equation to start to solve. So I usually and typically always, to get the variables together, I like to bring the smaller variable over to the larger. You don't have to, but it is just much easier for you to do so. So like, because of a lot of reasons, it keeps you in the positive. So if you do the inverse operation of positive 4, it is negative 4. So you're bringing the negative 4 over to the positive 10x. And what happens is that the 4's cancel out on the right side. And basically, you're bringing that 4 over to the left side. So this becomes a 6x plus 20. Bring down the equal sign and bring down that negative 40. And you just go ahead like you would normally solve any two-step equation. You subtract 20 on both sides. This cancels. You have 6x equals negative 60. Again, put it in your calculator if you need to. And then you divide by 6 on both sides. And x equals negative 10. And that is your answer. All right. And so we're just going to go and practice some more. It says identify the first step. The first step is to get the x's together. I'm going to bring the smaller x over to the larger x. Again, not necessary to bring the smaller over to the larger, but I do want to stay in the positive if I can, especially for a lesson that is coming up where you have to solve inequalities. It would be nicer to stay in the positive. So then you add 3 on both sides like you would normally do in any two-step equation. This cancels. I'm going to move this down a little bit. We have 2x equals 24. And then you divide because, again, you see multiplication and you get x equals 12. I'm going to bring this smaller. The smaller is the negative 5y. I'm going to make that a positive because the inverse operations, the opposite of negative is positive. So I'm adding 5y to both sides. This cancels. And then 7 plus the 5 is 45. And then you have a two-step equation. So you add 3 on both sides. I don't know why I made that like that, but it's adding 3 on both sides. This cancels. You get 12y equals 48. This cancels, and you get y equals 4. And that's it. Just get the, like when you see the variables on opposite sides of the equal sign, that's when you have to bring the smaller over to the larger. You don't have to, but you should combine the variables somehow, some way. Bring that over first. Don't worry about the numbers, the other numbers, the first. Just the numbers with the variables, the coefficients with the variables, get them together first so you can start to solve the equation. So here's some more questions. Again, we're going to just move the smaller over. Sometimes it would be better to get the larger over to the smaller. That is fine. As long as you combine these variables, you will be okay. We want to stay in the positive as much as possible. And as I work here, it's x equals 6. Try not to turn it around at all. Just leave the x where it is. It's on the right side, equals 6 on the left side. It is fine. All right, the smaller here is the negative 5, so I'm going to add the 5x on both sides. I don't want to bring over the 6x over to the 5 because there's a lot of reasons why. But again, it's just much easier to do it this way. I mean, you could do it the other way. It's fine. You could always bring the larger over. It's just that you might not know what to do as far as that goes. All right. And there will be an instance that we do bring the larger over to the smaller. It just makes more sense. And we'll go over that. But for these, again, you just grab the smaller variable, the smaller coefficient of that variable, bring it over. This cancels. You get 4x plus 12 equals negative 4. And you see, you're just looking at that two-step equation that you've always seen, that once you get it set up that way, it's kind of like you're a machine and you're going to solve this no matter what. Like, you know, you're not even thinking about what the steps to take because you're so used to taking those steps. It's 4x equals negative 16. And you divide by 4 on both sides. And the 4's cancel. And you get x equals negative 4. This one, just remember, you have the smaller x over here. So a lot of people will look at the negative 3x and say, oh, I'm going to just add the 3x on both sides. Now, I'm going to do this on purpose and show you when you bring over the smaller x over to the larger, it's okay. It's just that now you're going to be in the negative. And it's not the end of the world. You just don't get confused at what you're doing. Just always keep in mind that you are, your goal is to isolate the variable. So, and this negative 7x plus 3x, you put that into the calculator just like this. It's negative 7 plus 3, and it's negative 4. So you have a negative 4x, and you see how you're in the negative? It's okay that you're in the negative. Now you're adding the 22 on both sides. And this is not the way that I would do it, but again, we're going to come out to have that answer, that correct answer. We have 24 over here equals, and this cancels, and you get negative 4x. I need some more room. Divide by negative 4. Divide by negative 4. This cancels. X equals, and this is negative 6. Remember, 24 divided by negative 4, just like that in the calculator, negative 6. Just check everything with the calculator. And that is how you do those two. Like again, I would have added 7x on both sides. If I add 7x on both sides, I have a positive 4x here, and then I would minus 2 on both sides. I would have a negative 24. I would come out to have the same answer. It is a negative 6. All right, let's lesson check to solve the equation on your own. Just want to make sure that you understand how to do and what steps to take. You see parentheses, you just go ahead and use distributive property. So you have 5c plus 4 equals 2c minus 10. Then I'm going to go into getting the smaller c, smaller coefficient variable. Over to the larger. This cancels, and you get 3c plus 4 equals negative 10. And it's going to subtract 4 on both sides. This cancels, and I'm going to put it up here, 3c equals negative 14, and I'm going to go divide by 3. C equals negative 14 over 3. Notice that I do not see that right there. So I'm going to put negative 14 divided by 3. And I still don't see that. So what you're going to have to do is just to, obviously, this is negative 4.666. So it's not negative 1/3. This is common sense. Negative 2, it's not negative 3. It has to be this one, right? Negative 4 2/3. That's what this is. But we want to make sure that we could see with how to put this together in a how to make this like this. All right, a mixed number. So I'm just going to go to alpha y. And you see this right here, number 3. That's that shortcut that I was talking about. I'm going to try to choose number 3 and see if it works. But it's not going to, because, let me just clear it out. All right, you see it's a decimal. So if we have pressed math, it gets a little confusing here, right? But if you press alpha y, then this comes up. I want it like this because that's what I have here. So I press 2. And I'm not going to press 2. I'm going to press 4 because I want to get it to a fraction and see if that works. All right. So it's going to take my answer and move it to a fraction. Now, still, it's not there. It's negative 14 over 3. That's basically what I had. So now, but now I could do, let's see if I could have this go from a fraction to a mixed number. All right, so 3. And boom. So it's a little bit of finagling to get it to where it is, but you could really pick this choice anyway. What I would do is, as soon as I get a decimal, I'm just going to go like this, alpha y, and I'm going to just pick 4 to make it a fraction, to make that decimal a fraction. Once I make it a fraction, then I could pick 3 to make that fraction a mixed number. And that's like the playing around that you have to have there. So this is negative 4 and 2/3. All right. So don't be afraid of this question. All right. Get the x's together. That's what you do. Bring the smaller over to the larger. So 11 divided by 3 is definitely than 2 over 3. Right? So we're just going to, and if you don't know that, then just go ahead and put it in the calculator. It's larger. But again, you just want to get the x's together. And obviously, you're going to bring the 2 over 3x over to the 11 over 3x because the 11 over 3x is the only thing on that side, that right-hand side. So you want to get that over and to start to isolate it. So this cancels. You get 12 equals an 11. The way you subtract fractions is just, and it has the same denominator. Just go back to, like, I don't know, 3rd, 4th grade. When you're subtracting the fractions and you have that same denominator, the same bottom number, you could just subtract the top numbers and keep that same denominator. And what the good thing is, you could put this directly into your calculator and you won't have to worry about it. So I'm just going to put alpha x, just get to that fraction symbol, 11 over 3 minus alpha x, 2 over 3. And you press enter, and it's 3. It's 3 because it becomes 9 over 3. Because 11 minus 2 is 9 over 3. It is 3. 9 over 3, 9 divided by 3 is 3. And you just divide by 3 on both sides, and you get x equals 4. It looked like a difficult question. It's not. All right. So just remember, consider the equation below. These are going to get more and more complicated, but just remember, take it step by step. Every step that you take, know what you're doing. You could speak to it. This has parentheses, so you're using distributive property, 5 times x and 5 times 2. Bring everything down. Don't do anything else. And then decide what your next step would be. Do you see the left side has 3 terms? The right side has 2 terms? The 2 terms, leave it alone. See that that left side? It has 3 terms. So that means usually, not always, there will be like terms that you can combine. Once you combine those like terms, that would become a 7x, 5x plus 2x, and then bring down the plus 10. And then you have 6x minus 10. Then you would just get the smaller x over to the larger x, just like that. Inverse operations. This would cancel. you get x, that's 1x, plus 10 equals negative 10. You don't have to put the 1 in front of that x, it's understood. So you subtract 10 on both sides, just like that. This cancels, and then you get x equals negative 20. And here are some problems just to help you along. Okay, I did press this, and it didn't happen. Very good. All right, just use inverse operations. Bring the 3 over 2a down. This is 16. Just remember, when you're multiplying, multiply, if you have a fraction, multiply by the reciprocal. This cancels. A comes down. See how I wrote it as a 9 again? That is not good. A. And you, again, you take your calculator and you are going to put 16 times alpha x, 2 over 3. And you get 32 over 3, which I'm just going to put 32 divided by 3 is 10.6. So this is 32 over 3, or 10.6 with a line on top. And you see how it changes to a 7? That's just because the calculator really gave up and just said, okay, I'm going to just round that last number of the answer just to fit it on the screen. So do distributive property. You have 5x minus 5. Bring down everything, equal sign negative 6 plus 10x. Add the combine the like terms. It becomes an equation with the variables on both sides. I'm going to subtract the 10x on both sides, just like that. This cancels. You have 2x minus 5 equals negative 6. You're adding 5 to both sides. This cancels. And I'm going to move up to here. 2x equals negative 1. And divide by 2. And x equals negative a half. Again, with distributive property, we have 5x plus the 5 equals 15x minus 12 minus 9x. Then we combine the like terms. The like terms are right there. 15x minus 9x is 6x minus 12. Then I would subtract the 5x because that's the smaller. This cancels. You have 5 equals x minus 12. And you add 12 on both sides. And I'm just going to move this over here. X, this cancels. And we have x equals 17. For this one, again, distributive property, 6b minus 3 minus 7 equals 3b minus 13. This is 6b minus 10, combining those like terms. I'm going to bring the smaller variable over. See if I can get that. Nope. This cancels. We get 3b minus 10 equals negative 13. And you add the 10 on both sides. Let's see if it works now. Yes. This cancels. You have 3b equals negative 3. And you divide by 3 on both sides. This b comes down to negative 1. All right. Taking a look at this equation here, there's a lot of different ways that you could do this. I choose to look at this as a proportion. So I'm going to just use the crisscross method, that multiplication method. I'm going to multiply C times 54 in this case. And I'm going to go 54C. And then I'm going to multiply 24 by the entire C plus 20. So when I rewrite that, it's going to be like this, 24 times C plus 20. Just like that. And then I'll do distributive property. So this is 54C equals 24C. Plus, because this is going to be, it should be 480. It's going to be a positive, but I am going to check just to see if my math is correct. 24 times 20 should be 480, and it is, so we're good. Then I'm going to subtract the 24C. And when I subtract that, that cancels out just like that. This is 30C equals 480. And let's see, 480 divided by 30, 16. So C equals 16. And that is how I would do that one. All right, so this is a word problem, and it's not bad at all. When you have a square and an equilateral triangle, here's the square right here. This is the square. I wanted to highlight that, and we are not highlighting. And one of the things that you have to really kind of pinpoint on is that they have the same perimeter. If they have the same perimeter, guess what? These are equal. But just remember, the square has all equal sides. So I'm just going to put in x plus 3, x plus 3, x plus 3. And the equilateral triangle has all equal sides. That's why it's called an equilateral triangle. Right? Set up an equation that would help you solve for the missing variable. Well, you could just go ahead. There's 4 sides of this square. So we would put 4 on the outside, set it up like distributive property. They are equal, and there's three sides of the equilateral triangle, so you would set that up just like that. So I'm just going to rewrite this as 4x plus 3 equals 3 times 3x minus 1. I'm going to do distributive property on both. So this is 4x plus 12 equals 9x minus 3. Minus 4x on both sides. (12) equals 5x minus 3. And then you add 3 on both sides, and what do you know? You get x. You get 5x equals 15, and then you divide by 5, and it comes out to be a nice 3. So x equals 3. So it's asking you to find the perimeter for each figure. So we're just going to put square down. And that is 4 times the x plus 3. So the perimeter would be just 4 times 3 plus 3. 4 times 6. So the perimeter would be 24. And that's for the square. So I'm going to put that up here. For the equilateral triangle, I'm going to change my pen. For the equilateral triangle, it would be 3 times 3x minus 1. And the x is 3, so we're just going to put this as 3 times 3 minus 1. And we're going to make this 3 times 8, because that is 9 minus 1. And that would be, I'm not going to keep on putting the, that would be 24. So are they equal? Yes, they did say that they were equal. So that is kind of like a check. If they aren't equal, if you get the x and you substitute back in and it doesn't come out to be equal, guess what? You made a mistake. So that is the whole problem there. All right, here are some Regents questions and what we feel like, that you could see. Just remember, you have to get the x's together. Once you get those x's together, then everything becomes nice and easy. This cancels. You get -5 equals. This is 2 over 4, so I'm just going to put 0.5x. You don't have to. It's a half. You add 12 on both sides. It just makes it easier when you have a half, just to change it to that decimal. Like, might as well. This is 7 equals 0.5. And then you divide by 0.5. And if you did keep it a half, you just multiply by 2 on both sides. And that would become x equals 14. For this one, again, when you have a Regents, this was a Regents problem in 2021. So I'm just going to rewrite the problem. just like that. And then I'll do distributive property. This is 7x. We're going to combine like terms. Minus 24, 8x plus 4. See how nice and easy this is. Minus 7x on both sides. Inverse operations all the time. That cancels. Bring down the negative 24. Equals x plus 4. You minus 4 on both sides. And guess what? X equals negative 28. And that's your answer. It's a Regents problem. Nice and easy, not too difficult. So create an equation to solve for the dimensions of the rectangle. It's the same type of question as the square and the equilateral triangle. Just remember, a rectangle has the sides of a rectangle. The parallel sides are equal to each other. So this side would be 2x plus 3. That side would be x. Let's set up an equation to solve. We would have 2 times the 2x plus 3. Remember, when we're talking about perimeter, adding up all the sides and setting it equal to the given perimeter, just like that. So when we are solving an equation, I like to rewrite this is 4x plus 6 plus 2x equals 36. Nice and easy. 6x plus 6 equals 36. You minus 6 on both sides. It now becomes 6x equals 30. And you divide by 6 on both sides. You get x equals 5. So to find the length is this right here. This is the width. This is the length. So the length would be 2 times 5 plus 3. That's 13. And the width would be x is 5. And the exit slip. Which equation has the same solution as this mess? All right, so what I would do is really just take one step, then look. Take one step, then look. Let's see if we can see exactly what's going on here. So we have a half times 6. A half times a number is just half the number. If you put it in the calculator, you could see exactly that a half times 6 would be 3. And then minus a half x. Then plus 3x equals a half x minus 8. So the one thing that I'm kind of looking at right here is there's a lot of things I could look at, but you could see right here that I should combine like terms here in this case. And maybe we could see like what's going on the right side. We have half x minus 8 on the right side here. So you could see I'm going to highlight this. If you have half x minus 8, and both of these are half x minus 8, I'm not saying, like, I mean, you should probably look at A and B and see exactly what's going on. Let's do the next step. And this is 3, so I'm just going to put the 3 here. And then I'm going to put 3. We're going to put 1/2 alpha x, negative 1/2. And what is it? Negative 1/2 plus 3. And let's see what I get. 5/2. So this is plus 5/2 x equals 1/2 x minus 8. That's this. C is your answer. I took 2 steps. All I did was distributive property and combine like terms, and I got the answer. So there's other ways to do it, but it's just like, you know, just take it step by step and you could roll through like that. Here's a fast finisher, and pretty easy fast finisher. No fractions involved. Just do distributive property. You have 3x minus 12 equals 2x minus 12. And subtract on both sides. Get the smaller x over to the larger x. This cancels. You have x minus 12 equals negative 12. And you add 12 on both sides, and guess what you get? You get x equals 0. And that's fine. All right. And just remember, always when you're talking about an equation and you're solving for that variable, just remember to use those inverse operations. You have addition and subtraction, those are inverse. Multiplication and division, those are inverses. Square and square root, that's another set of inverse operations. So that is what will take you to eliminate and to isolate the variable and to eliminate everything else. And just remember, when you're solving an equation, you always have to have that variable alone on one side of that equal sign, and then you will know that you're finished solving that equation. All right. All right. Thank you for watching, and I hope that helped. See you next time.